We are working on the Minesweeper project from the YByte Python curriculum available at www.ybyte.in. Previously, we saw how we updated the mine info into the feed list. So wherever we have a mine, let's say on the board, the feed list contains a 9. Next task for us is to update the neighborhood info in the same feed list. But before doing that, we need to find a mechanism to find the squares that are in the neighborhood of a given square. Now, what do we mean by this? Basically, we want to find the row and column index of every neighbor of a given square. This is in fact an interesting problem. The reason is there are several cases. Notice that each square can at most have 8 neighbors. That's the geometry of the whole situation. But not every square has in fact 8 neighbors, which results in many situations which must be handled cleanly and carefully. Let me just try to illustrate my point here. Basically, I'm going to look at all the squares and think of them as being in 3 categories. First, I have the center squares, which are those which are shaded, let's say in blue over here. Basically, these squares have all 8 neighbors. For example, let's say I look at this square. Now, this square would be row 2, column 1. So that's called 2, 1. Its neighbors are those that are in the row above, which will be, let's say, 1, 0, 1, 1, 1, 2. Row below, which will be 3, 0, 3, 1, 3, 2. And on the same row, left side and the right side. So this will be 2, 0 and let's say 2, 2. Basically, all 8 are the neighbors. And this is the story with all the cells, all the squares that are, let's say, in this blue zone. Next, we have, squares that are in the red zone, which are on the edges. Now, first thing, notice that these have 5 neighbors. And the location of the neighbor depends on the square itself. For example, for let's say this square over here, the squares that are falling in this zone of C are the neighbors, whereas for this square over here, the squares that are falling in this inverted C are the neighbor. Likewise, we can see for the up and the down edges. Finally, we have squares on the corners. Now, these clearly have 3 neighbors. For example, these 3 in this case, and the xy values, or say the location of these neighbors, depends on the xy value of the square itself. Now, the point I'm trying to make is that depending on where the square is, we need to be handling all of this differently. In fact, specifically, for example, let's say a center square is relatively simple. I can make a list of all the x and y values, let's say, of the neighbors which are coming from, say, all these 8 places. But I definitely need to do something more, something special for the edge cells and the corner cells, because not only do they have lesser number of neighbors, but the location of the neighbors is also different. In this case, for example, is left, up and down, but it will be reversed, for example, here. So something special has to happen. Our approach is quite interesting. We are going to start assuming that every square is in fact a center square. It is not, but we'll start with that assumption because that helps to keep the code clean. So let's think about it. I think of, let's say, this square, which is given by 2, 2 as a center square. Everything is fine because I can now make a list of the x and y values of, let's say, or say the row and column index values for, let's say, these 8 squares, and I can create a list. In fact, for the actual center squares, that is the list of neighbors. When it comes to, for example, the edge square or the corner square, I can still start with that because I can just visualize hypothetically that, look, there are some squares over here which obviously are not there. Once I create this, I figure out that this is a corner, let's say an edge cell or a corner cell. I can just prune out these items from the list that I create. Now that way the code can remain quite neat, quite let's say clean and easy to understand. Now we are going to start writing this function in the next video, but I hope the approach is clear, because once we have clarity on the approach, then the code actually just follows from there. I hope you found this interesting. At YByte, we always build activities in similar step-by-step manner and discuss our approach, our thought process in a lot of detail so that the entire process becomes useful and enjoyable. Look at our website for many such activities and many such videos. Take care. Thank you so much. Bye-bye.